Good morning. Welcome to the lecture session on sampling distribution 1 from the module 5. In today's video, I am going to discuss about what is sampling and what are the objectives of sampling, meaning, population and the prerequisites for sampling. So, why do we require the sampling? Main objective of the sampling. All these things will be discussed in the today's videos. So, sampling denotes the selection of part of the aggregate statistical material with a view to obtaining information about the whole. So, population is a part, that is the aggregate or totality of statistical information on a particular character of all the members covered by an investigation, is called the population or universe. Next is a sample. The selected part which is used to ascertain the characteristics of population is called sample. Next comes the population size. It is the total number of members of the population and is denoted by capital N. Sample size. It is the number included in the sample and is denoted by small n. The main objectives of the sampling is to obtain the maximum information about the population with the minimum effort, to state the limits of accuracy of estimates based on the samples. Some of the important types of sampling. Random sampling. Here, the sampling must be random. It is the method of selection of a group of units in such a manner that every unit comprising the population has an equal chance of being included in the sample. Next comes the purposive sampling. When the sample is selected based on individual judgment of the sampler, it is called as the purposive sampling. Next is the stratified sampling. The population is subdivided into several parts called strata, and then subsample is chosen from each of them. Then all the subsamples combined together give the stratified sample. Next we have the two types of sampling mainly, that is sampling with and without replacement. So for example, sampling with and without replacement, how it will be done means, if we want to test in a production of S unit, like for example they have done some bulbs, production of the bulbs in a carton box consisting of 200 bulbs, whether the bulbs are all of good quality, the duration and the glow and voltage, etc. Everything, if they want to check, they cannot check before delivery for all the bulbs, that is 200 bulbs in the carton box. Instead, what they can do is they can select only some sample of 10 bulbs randomly in the box, and then they will go for the quality check, so that it will be taken for granted, or it will be assured that in the box consisting of all the 200 will be having the same quality as that of the 10 which we have chosen. We will not be selecting all the 200 for testing. So what we will do is, There are two types again. One is sampling with replacement and the other one is sampling without replacement. What is sampling with replacement means? After selecting the 10 bulbs for the testing, if we keep them aside and one more set of 10 bulbs is chosen from the remaining 190 bulbs, then it is without replacement. Whereas if I select the 10 bulbs and send it for quality checking, and after quality checking again I will replace back in the carton box so that it will become again 200. Now I will select another 10 that may include the bulbs which we have already tested. So two times it may happen to test. So sampling where a member of population may be selected more than once is called as a sampling with replacement. If the member cannot be chosen more than once, it is called as sampling without replacement. Next is the simple sampling. The simple sampling is a special case of random sampling in which which are independent and the probability of success is a constant. The word statistics is often used for random variable or for its value. Next is the sampling distribution. Let us suppose that we have different sample of size n drawn from the population. For each and every sample of size n, we cannot compute quantities like means, standard deviations, etc. Obviously, these will not be the same. Suppose we group these characteristics according to their frequency. The frequency distribution so generated are called as sampling distribution of mean, standard deviation, etc. The sampling distribution of large sample is assumed to be the normal distribution. Next, the standard deviation of sampling distribution is also called as the standard error. The reciprocal of the standard error is called a precession. Sampling distribution of the means and sample variables. Sample mean is a statistic and we discuss the sampling distribution of the statistic. We consider all possible random samples of size n and determine the mean of each one of these samples. We discuss the sampling distribution of the sample means for the two possible types of random samplings, that is with and without replacement, associated with the finite population. Next comes the random samplings with the replacement. Here the items are drawn one by one and are put back to the population before the next draw. If capital N is the size of the finite population and small n is the size of sample, then we have n power n samples. The mean, that is x bar, of the frequency distribution of the sample means will be equal to the population mean, that is mu. The variance sigma square x bar of the frequency distribution or the sample means will be equal to the sigma square by n, where sigma square is the variance of the population. Hence we have mu x bar is mu and sigma x bar square is sigma square by n, where sigma x bar is also called as the standard error of the means. Next comes the random samplings without replacement. Here, the items are drawn one by one and are not put back to the population before the next drawn. In this case, there will be NCN samples and we have the following results in accordance with the notation. That is, mu x bar is mu and sigma x bar square is n minus n by n minus n 1 into sigma square by n, or this n minus n can be denoted as c into sigma square by n, where c is n minus n by n minus 1 is called finite population correction factor. If n is very large, c is closer to 1 as we have the limit n tends to infinity, n minus n by n minus 1 is 1. Next, the standard error. The standard deviation of the sampling distribution is known as the standard error. It plays an important role in the theory of large samples and it forms the basics of testing of hypothesis. Next, a statistical hypothesis. A statistical hypothesis is an assertion or a conjecture, assumption and guess about the distribution of one or more random variables. Coming to the testing of hypothesis, the hypothesis formulated for the purpose of its rejection under the assumption that it is true is called a null hypothesis and it will be denoted by H0. And any hypothesis which is complementary to the null hypothesis is called as the alternative hypothesis and is called the alternative hypothesis denoted by H1. Some of the examples are: to test whether a processor B is better than a process A, we can formulate the hypothesis as there is no difference between the process A and B. Next, to test whether there is a relationship between two variables, we can formulate the hypothesis as there is no relationship between them. Next comes the critical region. A region corresponding to a statistics in the sample space S which amounts to rejection of the null hypothesis H0 is called the critical region or the region of rejection. The rejection of the sample S which amounts to the accordance of H0 is called a acceptance region. Thank you.